So we're doing work examples of theoretical probability, and you should already know your formula for that. Now, it says the probability that an event occurs is equal to the number of ways that event can happen over the size of the sample space, the number of the sample space. So here's our first example. We have a spinner and we're going to spin it and it's going to land on one of these 8 numbers. Alright, find the probability that the spinner lands on the number 3. Now, it's simple. We just take our formula and we substitute all of our numbers in here. So we want to find the probability that it lands on the number 3. Now that's going to be equal to the number of ways that you can get a 3. Now there's only one way to get a 3. It's sitting right there. That's the 3. So there's only one way to get a 3. And then we're looking for the size of the sample space. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 things in the sample space. So the probability of getting a 3 if you spun this was 1 in 8. Find the probability that the spinner lands on an even number. Now again, we look at our formula. The probability that it lands on an even number is equal to the number of even numbers we can see. 2, 4, 6, and 8. That's 4 even numbers over the size of the sample space, which I don't have to count again. We know that that's 8. Now, of course, I should simplify this. 4 over 8 is 1/2. So this time we're looking for the probability of a number less than 4. So the probability of a number less than 4. Now, that's going to be equal to, let's do our sample space first. That's the easy bit, 8. What about this bit? A number less than 4. 1 is less than 4, 2 is less than 4, 3 is less than 4. What about 4? 4 is not less than 4. 4 is exactly 4, so we can't include the number 4. So the answer is 3. A lot of students make the mistake here seeing a number less than 4 and they say 4, 3, 2, 1 and they write the number 4 here instead of the number 3. Be careful, less than means less than, not equal to. Now I'm going to do this one because I really won't want you to fall into any traps with this stuff. So less than 4 and odd. Okay, what were the numbers less than 4 again? 1, 2, and 3. I'll just write those down. 1, 2, and 3. Okay, what are the odd numbers? 1, 3, 5, and 7. 1, 3, 5, and 7. So now that we've got these, we really need to consider only the ones that are in both of these piles because we've got this and word here. Less than 4 and odd. Now, 1, 2, and 3 are all less than 4. And odd. So 1 and 3 are the odd ones. So 2 isn't going to work for us. Less than 4 and odd. 1 is less than 4 and 3 is less than 4. Not 5 and 7, so they don't work either. So it's only these numbers 1 and 3. 2, 5, and 7, they're no good to us. After that, we're just going to put it into our formula. So the probability that it's less than 4 and odd is equal to the number of numbers that are like that, only 1 and 3, so that's 2, out of the total numbers. 8 is 1 out of 4. Now it's very hard to talk about theoretical probability without talking about cards. Everyone does it. There's maths questions about it, so we've got to talk about it. Alright, so there are 4 suits of cards, clubs, spades, diamonds, and hearts. And there are 13 cards in each what we call suit. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. Alright, let's get started. So we're going to find the probability that if we draw one card from this deck of cards that it is a diamond. So the probability that it is a diamond is equal to the number of diamonds there are. Here are the diamonds, 13. There's 13 in every suit. 13. And the number of cards, you can count them all up, but there's 13 times 4, there's 52 cards in a deck. So 13 over 52, 1 in 4. So a king or queen. So the probability that it is a king or a queen is equal to, we can see that there's 4 kings here, we can see that there's 4 queens there, so there's 8 total kings or queens. So 8 out of 52. And I'm sure we can simplify that. Divide top and bottom by 4 and we'll get 2 out of 13. Now this question here is a question that maths teachers love to put in exams because it sort of tricks you up a little bit. So in this previous question, king or queen, it was simple. We counted up all the kings, we counted up all the queens, 8 in total. This one looks the same, right? Ace or spade. Now, aces, there's 4 aces, and spades, there's 13 spades. So a lot of people will say, well, 4 plus 13, that's 17. So there's 17 ways for this to happen. But that's wrong, right? Because one of the aces is a spade. So there's an overlap, and overlaps are a really important idea in probability. So this ace right here is an overlap. If we count all these, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, you can see that we counted that ace twice. That's a problem. So it's not 17, it's actually 16. We have to think about our overlaps. And of course, 16 over 52, because there's 52 cards, simplify, we get 4 over 13. And another little tricky one here, similar idea, but it plays out a little bit differently. A queen or a heart, but not both. All right, so here are our queens, 1, 2, 3, 4. So we can see that there are 4 queens. I'm just going to write that down. Queens, there's 4 of those. Hearts, all right, there's our hearts there. And we know that there are 13 hearts. And then it says this weird thing, but not both. And there's only one thing that's both. That's the queen of hearts. This thing here is a problem. All right, so queen and heart is equal to 1. And so then you might think, okay, so I've got this covered now. So probability queen and heart, not both, is equal to, all right, there's 17 queens and hearts all together, and then subtract this 1. But no, that's not quite right, because that 1, there's one of those in the queens, and there's one of those in the hearts as well. Now, we can easily just count these up, and we'll see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, skip the queen, 12, 13, 14, 15, because we have to subtract the 1 from there and subtract the 1 from there. So 15 out of 52 is our final answer here. There are 15 ways to get a queen or a heart, but not both. All right, that's theoretical probability. It's a very simple idea coming from a very simple formula, but you need to be a little bit careful when these questions get a little trickier.